So doing some applications with logs and solving equations with logs, we get compounded interest. And compounded interest is basically what your interest is. You get your interest, it becomes part of the investment. And so now you're earning interest on that interest itself. So this is a good thing, unless it comes to college loans, and then that's not a good thing. Interest compounded K times per year. So here's our basic formula, and this works for 1 time a year, 12 times a year, which would be monthly, 4 times a year, which would be quarterly. And our formula that we have is A is equal to P times 1 plus R over K raised to the KT. So let's see what that is. So P is your principal. Principal is what you're starting off with, what you're investing. R is your rate. Make sure that when we're dealing with this rate, this is as a decimal. So you have to convert it usually from a percent. K is the number of times it's compounded. So if they're saying monthly, quarterly, so monthly would be like 12, quarterly would be 4, and then T is your time in years. So make sure that we know that. Okay. So using that idea, so suppose Mike invests $500 at 7% interest compounded annually. We want to find the value of his investment after 10 years. So if he's investing $500, that becomes the P of the problem. 7%, so now we need to turn it into a decimal, so that's 0.07. Compounded annually, meaning 1 time a year, so that K value is now 1. Okay, plugging it into the formula, I see I have 500 times 1 plus our rate of 0.07 divided by 1, K times year. Okay, and then we raise that to the 1 times, and it says after 10 years, so 10. Okay, this is a nice kind of plug and chug. You can enter that all into the calculator, simplify that out. Sometimes I do recommend maybe simplifying within the parentheses first, just to make sure you've entered it incorrectly, but the inspires are super sweet. You should be able to type in the same thing, looks exactly the same on your screen, and then if you press enter, you know you've done it correctly. Once you've entered this in, keep in mind this is money, so when you're rounding, this is a 2 decimal place rounder. So we get $983.58. So that's pretty good. Okay, taking a look at another one. So we're going to find the amount accumulated after investing $23,500. So that's your P value, your principal, for 25 years. That's your time. At an interest rate of 4.5%. So again, keep in mind, making that a decimal, that's going to get you 0.045. Compounded monthly. So monthly being 12, that's going to be your K value. Okay, so again, we're finding that amount. I'm looking for my total after all of the compounding. Principal value is 23,500. We have 1 plus our rate. Rate is 0.045 divided by the number of compounding times, which is 12. And then we're going to raise that to the 12 times 25, so KT. And again, here's another plug and check. You can just plug this right into the calculator, keeping in mind this is money, so hundredths for the rounding, and we get 72,232.95. And I would encourage you to please try this on your calculator and make sure that you're getting the same answer that I'm getting, so that we know that we're typing this in correctly. Now notice this is a little different. So Stephen has 500 to invest against still your principal. It's asking us what is the annual interest rate. So now we're solving for R. Compounded quarterly. So there's your K value, quarterly being 4. And it says is required to double his money in 10 years. So 10 is your time. Doubling his money, that's telling you that A value, what you get at the end. So if he starts off with 500, if I were to double the 500, there's my 1,000. Okay, your principal is being 500. We have 1 plus the rate. We don't know the rate. We're solving for the rate this time. Divided by K. K is the compounding amount, quarterly being 4. And then we're going to raise that to the KT. So 4 times 10. Okay, so not a plug and chugger this time. This time we actually have to solve this out. We have to think orders of operations. So first thing that we can do is not only simplify 4 times 10, but divide everything through by 500. Okay, so on our left-hand side, we get 2. Still have 1 plus r over 4. I can't really do anything with that. And it's raised to the 40. So just like we've done before, we can introduce a log because I want to try and bring this exponent down in front. You could do log, you could do natural log, as long as it's consistent on each side. And so now we have something that looks like log of 2 equals 40 log of 1 plus r over 4. Okay, divide each side by 40. So if I'm dividing this by 40, divide this by 40, we're going to get, and again, all on your calculator, 0.0075257. If I could recommend, I probably would just leave this number in my calculator and use that answer feature on your calculator. If you want to write something down just so that you have a value in mind, you could write that down. I would take as many decimal places as you can. Now, we want to get rid of this log. And keep in mind, this is a common log, log base 10. So what are we going to do? Well, in order to undo a log, I have to introduce its inverse. Well, if it's a log base 10, the inverse should be an exponential function 10. So if I do that on one side, I do that on the other. These reduce out. I'm left with 1 plus r over 4 on this side. And on the other side, I could plug this into my calculator, get a decimal, and I get 1.0174797. Again, try and keep that in your calculator so that you have less rounding. Okay. Subtracting over the 1. And then multiplying each side by 4, we're going to find 0.0699 for a rate. And if we were to turn this into a percentage, you could say the rate is just about 6.99%. Okay. We're going to try some more on the back. The only difference with on the back is now we have something called compounding continuously. So we can either compound it a different number of times per year, so that was that last formula that we used, or compounding continuously, now we get a slightly different formula. I like to call it APERT. So the only thing that's really changing here is we lose that set of parentheses, and now we have it as the principal times our base E raised to the rate times time. Okay, so we're going to take a look. So Latasha invests $100, there's your principal, at an 8%, there's your rate, annual interest compounded continuously. So as soon as I see this, I think APERT. Continuously is the only time you're going to use APERT. So it says find the value of her investment at the end of each of the years 1, 2, and 3. So if I'm thinking year 1, okay, so we have our principal times E raised to the rate as a decimal times the time, it's 1 year. So again, here's nice plug and chug kind of things. Make sure that you are, though, plugging it in correctly. Try this on your calculator. This is, again, money, so we should be rounding to 2 decimal spots. So at the end of year 1, we have $108.33. Now, the only thing changed when we go to year 2 is our time. So same formula. So I have 100 E raised to the 0.08, now this time times 2. Okay. So final answer here, again, it's money. We're going to have a total of 117.35. And then again, if I did year 3, only thing that's changing is our time. So we have E raised to the 0.08 times 3. And again, if we plug that in, I can see we're going to have $127.12. So APERT's kind of nice. Okay, a little less that we have to worry about, but again, the only time we use this is when you do compounding continuously. Now we're going to take a look. Same idea, still compounding continuously. It's just now this time we're solving for something different. So Jerry has $1,200 to invest, so there's your principal, at an interest rate of 2.5% compounded continuously. How long will it take for his investment to grow to $25,000? So this time we are solving for T. I don't know what T is. Okay, so we have our amount at the end of the investment. We have our principal at the start of the investment, compounding continuously. So I have E raised to the rate as a decimal times the time that we're solving for. Okay, orders of operations, need to divide through by 12,000 on each side first. So we have E raised to the 0.025 T on this side. On our left side, again, so we're going to get decimals. I would encourage you to leave this in your calculator and just keep using that answer in your calculator. Solving for T, T is an exponent, so I have to think I need the inverse operation of E, which is our natural log. What you do to one side, you have to do to the other. So on our right-hand side, I have 0.025 T, and on our left side, we have natural log of the answer that you've left in your calculator. And then to solve for T, I'm dividing through by 0.025. And we're going to find time. It's about 29.36, about 29 1/3 years. Keep in mind, time is always years. And we could use the same concept if I wasn't solving for time. We could do that same process to solve for rate. It's just a different variable that we'd be looking for. So R versus T. So same idea. All right. Hope you like this. Hope this helps. Don't forget to like and subscribe. Have a great day.